This is an animal that spends its entire life thousands of feet below the ocean, in a place where sunlight never arrives, where the water is freezing cold, and where the pressure is so intense it would crush a human instantly. Down there, its body is perfectly designed for survival, shaped by extreme conditions that we can barely imagine. But the surface is a completely different universe, and the journey upward triggers a violent chain reaction inside its fragile body. An anglerfish is not built for our world, and the moment it reaches the surface, its body begins to fail. It lives under crushing pressure, sometimes more than 300 times the pressure at sea level. Its tissues, its organs, even the tiny spaces inside its cells are adapted to exist in that constant squeeze. When an anglerfish is accidentally caught in a deep-sea net and pulled upward, the pressure around it begins to drop rapidly. Unlike divers, it cannot adjust slowly. Unlike surface fish, it does not have the biological systems needed to regulate such dramatic changes. As the water pressure decreases, gases inside its body begin to expand, tissues start to swell, and its internal structure begins to distort. What looks like a strange, almost alien creature floating on the water is actually an animal that has been violently removed from the only environment it was ever meant to survive in. And what happens next reveals just how extreme life in the deep sea truly is. Most deep-sea anglerfish live between 3,000 and 6,000 feet below the surface, in a region scientists call the midnight zone. At that depth, sunlight disappears completely, and the ocean becomes a vast black space where vision is nearly useless, and survival depends on energy conservation. The temperature hovers just above freezing, food is scarce, and every movement costs precious calories. For every 33 feet you descend in the ocean, pressure increases. By the time you reach 3,000 feet, the water pressing down on a creature is hundreds of times heavier than what we feel at sea level. That pressure does not simply surround the anglerfish, it becomes part of its biology. Its muscles are soft, its bones are light and flexible, and its body structure is adapted to exist in constant compression. Unlike many shallow water fish, deep-sea anglerfish do not have large swim bladders filled with gas. Gas behaves unpredictably under extreme pressure changes, and in the deep ocean, that would be a dangerous weakness. Instead, their bodies are built to remain stable in a dense, crushing environment where nothing expands and nothing floats freely. Everything about the anglerfish is slow and efficient. It barely moves, conserving energy in the darkness. It uses its glowing lure to attract prey rather than chasing it. It survives by adapting perfectly to an environment that would destroy most other animals instantly. The anglerfish is not fragile in its own world. It is perfectly engineered for it. But the moment it leaves that crushing pressure behind, the very adaptations that keep it alive in the deep become the reason it cannot survive anywhere else. If you enjoy exploring how extreme environments shape life on our planet, consider being part of our community by subscribing to this channel. Because every episode reveals how nature pushes biology to its limits in ways that are both fascinating and unexpected. In the deep ocean, the anglerfish exists in perfect balance with the immense weight of the water above it. That pressure keeps gases compressed, stabilizes tissues, and maintains the structural integrity of its soft body. The moment it starts rising, that balance begins to unravel. With every foot upward, the surrounding pressure decreases, and the gases naturally dissolved in its blood and tissues begin to expand. This process is similar to what happens to human divers who ascend too quickly, a condition known as decompression sickness. But unlike trained divers, the anglerfish has no biological mechanism to regulate rapid pressure shifts. It cannot release expanding gases safely, and it cannot adjust gradually if it is being pulled up by fishing equipment at high speed. As the pressure drops, microscopic gas bubbles begin forming inside its tissues. These bubbles disrupt blood flow, stretch delicate membranes, and interfere with organ function. Its body, designed to be soft and flexible under compression, now begins to swell outward without the stabilizing force it depends on. The expansion does not happen evenly. Certain areas may bulge, internal organs can shift, and fragile structures that function perfectly in the deep may begin to tear or rupture under stress. What looks to us like a distorted or bloated fish at the surface is actually the visible result of internal systems failing step by step. By the time the anglerfish nears the upper layers of the ocean, its physiology is already in crisis. The environment that once supported every part of its biology has disappeared, replaced by conditions its body was never designed to survive. The first difference is pressure, which at sea level is only a tiny fraction of what the fish experienced in the deep. Without that crushing force pressing inward, its soft tissues lose the structural support they depended on. The gases that expanded during the ascent continue to push outward, and the body may appear swollen, distorted, or even partially ruptured. In some cases, the stomach can protrude from the mouth due to internal expansion, not because it is aggressive or strange, but because physics is now overpowering biology. The second difference is temperature. Deep sea waters are just above freezing, while surface waters can be dramatically warmer. That sudden temperature shift affects chemical reactions inside the body, disrupts enzymes, and places additional stress on organs that are already failing from decompression. For an animal that has evolved in total darkness, sunlight is overwhelming. The anglerfish's eyes are adapted to detect faint bioluminescent glows in black water, not direct exposure to bright daylight. Its sensory systems, tuned to subtle movements and low-energy environments, are suddenly flooded with stimuli they were never meant to process. Oxygen levels are also different near the surface, and while that may sound beneficial, its circulatory system is not designed to regulate these rapid changes under stress. Combined with internal gas expansion and tissue damage, this creates a cascade of system failures. To an observer, the anglerfish may look like a bizarre deep-sea monster brought into our world. But in reality, what we are seeing is a creature whose biology is collapsing outside of its natural pressure chamber. Unlike many shallow water fish that can move between depths, the anglerfish evolved in a stable environment where pressure rarely changes. Its proteins, its cell membranes, and even the chemistry inside its bloodstream are adapted to function under constant compression. When that compression disappears, those molecular systems begin to malfunction. Enzymes lose their proper shape, cellular processes slow down or stop, and tissues that once operated smoothly begin to break apart at a microscopic level. The expanding gases that formed during ascent may block circulation, damage organs, and interfere with oxygen delivery. Even if the fish were somehow returned quickly to deep water, the internal trauma caused by decompression would likely be irreversible. The swelling, ruptures, and structural distortions are not surface-level injuries, they are signs of systemic collapse. Although deep-sea anglerfish lack large gas-filled swim bladders like many other fish, they are still finely balanced for neutral buoyancy at extreme depths. That balance depends on density differences between their bodies and the surrounding high-pressure water. At the surface, where water density and pressure are drastically different, that equilibrium disappears. The fish cannot stabilize itself, cannot swim properly, and cannot return downward without assistance. In rare cases, submersible vehicles have observed deep-sea creatures brought closer to the surface in controlled environments, and even under careful conditions, the stress response is immediate and severe. And specialization in nature comes with a cost, because the more perfectly adapted an organism becomes to one environment, the less capable it is of surviving anywhere else. Down there, the anglerfish does not look like a victim of physics. It does not look distorted or fragile. It drifts with quiet efficiency, its soft body perfectly supported by the crushing weight of the sea. Its glowing lure sways gently in the darkness, a small living light in an endless void, attracting prey in a world where energy is precious and every movement must count. The pressure that would destroy a human submarine without protection is the same force that keeps the anglerfish stable. The freezing temperature that feels hostile to us is simply normal. The darkness that seems terrifying is, for this animal, a place of opportunity and survival. When one of these creatures is pulled to the surface, what we witness is not a monster emerging from the deep, but a life form removed from the only conditions it was ever meant to experience. The swelling, the distortion, the apparent strangeness are not signs of weakness, but evidence of extreme adaptation. Its body is not failing because it is poorly designed. It is failing because it was designed too perfectly for another world. The deep sea covers more than half of our planet, yet it remains one of the least explored places on Earth. Countless species live in that darkness, shaped by pressure, cold, and isolation in ways that challenge our understanding of biology. Each one is a reminder that life does not simply survive in extreme environments. It transforms to match them. And perhaps the most remarkable part of this story is not what happens when an anglerfish reaches the surface, but what happens every second it remains below, thriving in conditions that seem impossible to us. I hope you liked this episode. Until the next video.